where was that? 2 times 5 is 10, plus a negative 11 is a negative 1. 2 times a negative 2, negative 1 is a negative 2, plus a negative 7 is a negative 9. 2 times 2 is 4, plus a negative 32 is a negative 28. Now what's the simple operation that I do to make this a positive 1? Multiply by negative 1. So you can just write negative row 2, and then just change the sign of everything in row 2. 1, 2, 1, 5, 0. This is going to be 1, 9, 28, 0, 5, negative 1, 2. Okay, so you guys want me to finish this example? It's going to put us over on time. So I guess I can tell you, if you want to leave now, you're welcome to. If you want to wait till after I'm done, it might be 5, maybe 10 minutes. I don't know. It's up to you. Okay. Actually, I don't think it'll be too long. I'm just going to rewrite this thing so I can work with one sheet of paper. I'll try to get us out a few minutes early next time. So that's where we're at. I've got my first column. What do I need to do in this column? What's that? Yeah, what do I need to make this column look like? I need to make that a 0, and I need to make this a 0. Okay? How can I make this one a 0? Multiply the second one by a 2, and then doing what? And not adding, but subtracting. So usually I think about, when I multiply, I think about multiplying by a negative, and then I think about adding. Okay? So row 2 times a negative 2 plus row 1. Row 2 and row 3 are going to stay the same. Now notice the 0 is not going to affect the 1. That's a good thing. We don't want the 0 to affect the 1. 1 times a negative 2 is a negative 2, plus the 2 is a 0. 9 times a negative 2 is negative 18, plus the 1 is a negative 17. And then a negative 2 times 28 is a negative 56, plus 5 is a negative 51. I should say we want to make these zeros. Okay, so we do the same thing but for row 3, right? So how am I going to make this a 0? Row 2 times negative 5 this time. And then plus that to add that to row 3. So 1, 0, negative 17, negative 51, 0, 1, 9, 28, 0, negative 5 plus 5, good, got my 0 there. 9 times a negative 5 is a negative 45, plus the negative 1 is a negative 46. Okay, negative 5 times 28. Is that 120? 140. Negative 140? Negative 140 plus 2 is negative 138. Is that right? My guess, from looking at this, just my intuition says that I can divide this last row by negative 46 to make this a what? Remember your form that you want 1, so you want this guy to be a 1. And I guess if we divide by negative 46, my bet is that negative 138 divided by negative 46 is an even number. Make this a 1. So what's the operation that we're doing? Row 3 times 1 over a negative 46. Oh yeah, you could. Division is the same thing as multiplication. We're almost done, guys. I won't keep you more than 5 minutes over. 1, 0, negative 17, negative 51. 0, 1, 9, 28. 0, 0. So negative 46 divided by negative 46 is a positive 1. And you said, what was this, 3? Are we done? We just got to do 2 more operations. Notice that I've got to make these zeros. Okay? Make these zeros. Now, which row do I want to use to make them zeros, though? Good. Why, David? Yeah, whatever times 1 would make these zeros. But the other reason why is if I use one of the other rows, then when I multiply it by this number and then add it, then I'm going to start changing these first 2 columns. Since I've already got the diagonal, okay, once you've got a diagonal, you just want to use the one in that column. Because if I didn't use this row, and I did my operations, I'd start changing these numbers. And I don't want to change those numbers, because they're already in the form that I want. So, you guys try to finish it up. I'll do the same. I'm going to do row 1 first, so I'm going to multiply row 3 by 17 and add it to row 1. So 1, 0, 17, it goes away. Multiplying 3 times 17 is what? 54?
Negative 51.
Well, row 3 times 17, so 3 times 17 is 54. 51. And then minus a 51. So that's 0. Okay? And then the last one that I want to do, row 3 times negative 9, and then add that to row 2. So 1, 0, 0, 0, 0, 0, 1, 3, 0, 1. Negative 9 plus 9 is 0. 3 times a negative 9 is a negative 27. Adding that to 28 is a positive 1. All right. So my solution is, what does the first equation tell me? Not 1 equals 0.
1x plus 0y, 0
Right, so then it's not 1 equals 0, but x equals 0. This is a y equals 1, and this is a z equals 3. And so my solution is the point 0, 1, 3. All right, sorry to keep you on that last example. I did want to make sure I went through one though. You guys can do it. Promise you can. And we even didn't get to go to the section that I wanted to go. But that's okay. Homework. I wrote it on the back of one, so let me rewrite it. 3.2. 13 to 35 odd. I'll post it online if you don't want to stay, but if you want to, I'll write it up. 47, 57, 59, and 61. That's a total of 16 problems. Section 3.3. 7 through 19 odd. That's a total of 7 problems. And then 3.4 is 13 through 35 odd. That's a total of 12 problems. So 28 plus 7, 35 problems. That's your homework. Yep. Okay, so what's due on Thursday? If you go to Blackboard, and go to the assignments, you can look at it there, but I'll demonstrate if you don't mind waiting. So you've logged into Blackboard, right? Okay. So when you go to Blackboard, you go to your classes, you go over to the tasks again, the homework. I've already started a homework 2, so if you click on the homework 1, not the arrow, because that'll just mean you change it, right? If you click on homework 1, I changed it up a little bit. I said that this is the homework that I plan on collecting on Thursday the 14th. And that's the whole list. And I'm probably even going to take a few of those off. I'm probably not even going to worry about the first 4 sections. So there's the list that I'm taking up on Thursday. It has nothing to do with anything that we've done since last Tuesday. So if you did the homework from last Tuesday before your test, then you're done. So the last section that we did was part of 2.6. No, up to 2.6. But remember, it wasn't all of 2.6. Because I didn't finish all of 2.6 before the test. When I did the translation after the test. But this is the list. Everything up to here. And I'll be a little lenient on the first one. You know, if you're missing 2 or 3 problems, that's okay. You know, 2 or 3 problems for each section. But if you're missing 2 or 3 whole sections, that's not quite okay.
I have a question. So, I didn't know the opinion.
Okay, so here you still want to make this a 0, right? So how can I make that a 0?
Add row 1.
Right. So now if you add row 1 to row 2,
But won't this both become 0?
so this will also become 0, and that was the solution of the problem.
Oh, okay. So it's okay if I change the top one?
Yeah, that's just a multiple. That's the second operation, multiplying a row by some number.
Thank you.
Yep. Oh, you're talking about the matrix? Okay, elements. Remember the elements of a matrix. Okay, so you have a question about the matrix. So, yeah.
At the very beginning, you switched to
Yes.
Did that have any impact on the end result?
No, not at all. The point is that those 3 operations, switching, remember you have 3 rules. They're on the slide, what I've made. These are the 3 operations. You can interchange any 2 rows. You can multiply anything by a number, or divide, or add or subtract, right? The point is that if you do any 3 of those, it never changes the result. You always get the correct answer in the end.
So I mean, what I'm saying is, it doesn't matter if initially what you have is x was y, and now y just turned into x. Because this column is all the x's. Okay.
All I did was, it's like I took this equation and write this one first, right? When I switch the rows. You don't switch columns. You cannot switch. That's a great point, and I probably should have mentioned that in class. You don't switch columns, but you can switch rows. Good question. Good question.
I got confused, like when you said you had 6, 1, all that, already, like mark it down. But how did you get the end result? So it was like where you got me, like.
Okay, so the only thing I did, this thing?
Yeah, it's like how'd you get the second matrix part?
Oh, so all this was a goal, right? This is what we want our matrix to look like. So that doesn't really that doesn't really affect the problem. Okay, so that's not what you're asking about, is it?
No, because I wanted to know like how you get from here to like the. Because you know how you had to switch the rate and switch the rows.
Okay, well I switched the rows first. Okay, from here to here I switched the first two rows. Right?
Yeah.
Okay. Now okay, so then you just wrote it down again. Now from here to here, how did I make this one a 0? How did I do this? So I multiplied row 1 by a negative 6, and then I added that to row 2. So 1 times a negative 6 plus a 6 is what? Is 0. Now 2, now I've got to go in columns. 2 times a negative 6 is, and then plus a 1 is negative 11.
Yeah, that's what confused me.
Okay, good. Good. That's what all these little notations mean. It means row 1 times this number plus some other row. Row 3 times this number plus some other row.
Okay.
So see if that you can read it that way.
Yeah, because it kind of confused me for a little bit, and I didn't get onto it that easy.
Cool. Well, good question. I hope that helps.
I just have a good
Aggressive. All right. Yeah. You did it differently? Okay. You're thinking about determinants. Okay? Now, determinants are different than augmentation. So get that out of mind. Yeah, I'm glad I didn't talk about it, because it would have just blown everybody. So these were calculating determinants of things.
Oh.
It's totally different, but it's still working with matrices.
Yeah.
But it's totally different. So good. Yeah. Great question. I don't even think I might mention it Thursday. So you're good with this? You go practice it?
Yeah.
Got something challenging for you? Good. Good. Good.
I'll do anything with my
25th?
anything with substantial.
I mean, everything we do is substantial. I don't think that's not before spring break, right? It's not the Thursday before spring break. No, it's the Thursday before Steve starts. Was it next Thursday you're asking about? Or Tuesday? Or Tuesday?
25th is the last Tuesday of this month.
No, nothing substantial. I mean, we are doing 2, 3, 4 sections a day, and we just have to the way the time of the class is. It's a 3-hour class. 5 credit hours, it means twice a week. So, yeah. Again, I'll try to do the videos and post them online, so maybe you can watch the lecture anyway and catch up.
Yeah, because most likely it will be good.
Okay.
Yeah.
Oh, did you see that, I think it's National Geographic now has a program, I think it's starting this Friday, this live video from the space station.
Oh, I didn't know that. But they always do reporting to the space station.
Yeah, they're doing, I think it's National Geographic. So what's the Neil deGrasse Tyson Cosmos, the new version?
Okay.
And they're promoting this, I think every Friday they're doing a live video from the space station. What, I don't know, 5 years.
Yeah, I think they always do referring to the space station that they always NESPO always puts up on the website. For video feeds, and they always ask you their viewers.
Well, I think it's cool that it's live. It's supposed to be HD or good quality live in there, so that I think they're accepting questions from young people or just from the public, and live posing them to the astronauts on the station and receiving feedback, and the astronauts are answering questions and doing the things they do over there.
And it's on the NGO website.
It might be, yeah, I think it is. I'll double check if I see it again. I'm pretty sure it's National Geographic. It wasn't PDF that I was talking about. Yeah, so try that again. Yeah.
Just a random question. You must have already known.
Yeah, actually I've got a Raspberry Pi.
Oh, you're
But I really love having one on Arduino. Do you have one?
Yeah, I just got it. It's started. It's pretty cool.
Yeah, yeah.
Just really basic. It's kind of cool.
Yeah, which package did you buy?
The Uno?
Okay. And does that come with any like what do they call it, extension cords, whatever?
Yeah, I came with a little solid breadboard, I think it's called.
Yeah.
Just basic resistors, LEDs.
Right. Yeah. I did a bunch of that back in the day, and I got a Raspberry Pi for Christmas, and I would love to have an Arduino as well.
I mean, what can you use Pi for?
So Pi is a computer. It's not as much fooling around with the hardware as Arduino is. It's pretty much a computer, but it's running Linux. So I run Linux on my laptop. But you can. It's basically a whole computer in a tiny little box. And because it's Linux, you can program it to do whatever you want. Linux has just always been a playground for programmers, and so you can do it for all kinds of different projects. So one of the projects I've been working on, since school started, I haven't been able to do it, but I'm kind of into photography. So I hooked up my Raspberry Pi to my DSLR on a tripod, and you can do a couple of things, but to do time-lapse photos. So I just programmed my Raspberry Pi to make my DSLR take a shot every 30 seconds, and put them all in order, and then, make like a video. That's just like one little project. You can do all kinds of things. You can run a web server on it. You can plug it into the wall and run a web server off a little box that's half as big as my pencil box. Yeah. Man, keep me posted. Bring it in, man. Bring in the Arduino. I mean, if you have a project.
See, that's the thing. I know you can do so much. I don't know to do with this. But I was thinking, as well, stuff. Using that as a PWM time controller. You're reaching at a certain temperature.
Cool. Yeah, you do have some cool shirts, dude. So what brought you? Why the Android eating the Apple shirt? I mean, I think it's great, but what's your experience? Like, why did you go with Android versus Apple? I mean, is it?
I never really liked Apple. I remember having one of the first iTouches.
iTouches?
Yeah, it was one of the first iTouches, and it just sucked. I don't know. I just started going for Android more and more.
I didn't know if it might have been philosophical. Oh man, I'm recording this whole thing. The philosophy difference.